Hello and welcome to this pictorial guide on the implementation of a method for the verification of the labelling of previously frozen poultry by measurement of Hydroxyacyl-Coenzyme A dehydrogenase activity. This guide has been produced as part of the Joint Knowledge Transfer Framework for Food Standards and Food Safety Analysis, and which is funded by the Department for Environment, Food and Rural Affairs, the Government Chemist Programme for 2023 to 2026, the Department for Science, Innovation and Technology, formerly the Department for Business, Energy and Industrial Strategy, the Food Standards Agency and Food Standards Scotland. The procedure being presented may be used to determine whether raw chicken or turkey breast meat has been previously frozen. When meat is frozen and then thawed, the muscle mitochondria, a type of intramuscular organelle, are damaged during the process, and the enzyme Hydroxyacyl-Coenzyme A dehydrogenase, or HADH, as it is commonly referred to, is released into the intracellular fluid. The relative increase in the amount of HADH found in the intracellular fluid before and after freezing may be indicative as to whether the meat has undergone freezing. The measurement of HADH activity in the intracellular fluid, taken by pressing the meat and analysing the fluid using a spectrophotometer, is a simple, rapid and reliable procedure for a laboratory to undertake when evaluating the reported cryological history of raw chicken or turkey samples. HADH activity is expressed in terms of international units per milliliter of meat press juice, and where 1 unit represents 1 micromole of substrate converted per minute at pH 6.0 and 25 degrees C. The ratio referred to as R1 is that of the ratio of HGHD activities obtained for samples analysed before XO and after X1, a laboratory freezing step. Hence, we can express this as R1 is equal to HADH activity before a laboratory freezing step divided by the HADH activity after a laboratory freezing step. The procedure involves preparing 2 subsamples for each poultry breast sample. The first subsample is analysed immediately, and the second subsample is analysed after it has been frozen for at least 2 days at -18 degrees C plus or minus 2 degrees C. After thawing, where this is required, the meat juice is pressed from the sample, filtered, and then diluted with a phosphate buffer. The HADH activity is measured by measuring the rate of decrease in the absorption of a treated sample extract mixed with Hydroxyacyl-Coenzyme A at 340 nanometers using a UV spectrophotometer. The resulting ratio, R1, of the HADH activity for the original and laboratory frozen subsamples is then used to determine whether the meat sample has previously been frozen by comparison against threshold limits. As with any method using laboratory equipment, chemicals and meat samples, there must be consideration of hazards and risks in the procedure, not forgetting the sample may contain a bacterial hazard. This slide provides some of the processes that should be considered. Equipment required includes a meat press. This may consist of an acrylic plastic perspex container comprising a circular base unit and lid, and a G-clamp, illustrated later. These presses are not commercially available, but may be made by an appropriate engineering facility. Knife or scalpel. A sharp kitchen knife is required to cut subsamples from the poultry breasts. Although a laboratory scalpel can be used, a longer blade enables the samples to be cut more easily. A ruler. A plastic or metal 30 cm ruler is used for measuring the subsamples. If multiple samples are being analysed, a 30 mm template can be constructed from stainless steel or similar material. Plastic Petri dishes, or similar containers to catch the meat juice from the pressed samples. 25 ml volumetric flask. plastic or glass pasture pipettes, 0.45 micron pore-sized syringe filters, 25 mm diameter filters made of either polyvinyl, vinyl, PVDF or nylon, 5 ml plastic syringes, automatic pipettes capable of dispensing volumes between 50 microliters and 5 milliliters, timer capable of measuring up to 3 minutes to the second, UV vis spectrophotometer capable of measuring the wavelength at 340 nanometers. If possible, the spectrophotometer cell should be temperature controlled at 25 degrees C. However, this is not vital in normal laboratory operating temperatures, as solutions are attemperated before use and the measurement time is short. Plastic or glass cuvettes. Cuvette dimensions are 1 cm by 1 cm. Top pan balance, capable of measuring to 2 decimal place. Water bath, capable of maintaining 25 degrees C plus or minus 0.5 degrees C. Optional microcentrifuge, capable of centrifugation up to 14,000 G. Microcentrifuge tubes, volume of 2 ml. Reagents for the procedure are shown and information on how to prepare the solutions available later in the presentation shown in the Annex 1. It is recommended analytical grade reagents are used with deionized or similar quality water in the preparation of solutions. The procedure is described by the following 6 steps, which are further explained in the presentation. 1. Subsampling the poultry breast. 2. Pressing the poultry breast to obtain meat juices for analysis. 3. Preparing the meat juices prior to measuring HADH activity. 4. Measurement of HADH activity using a spectrophotometer, including quality assurance. 5. Calculation of HADH activity values and 6. Interpretation HADH activity values. 2 subsamples are obtained from each poultry breast measuring 30 mm by 30 mm by 25 mm using the following procedure. The skin and extraneous fat are first removed from the sample poultry breast. The breast is then trimmed so that a 25 mm thick strip can be taken from the thickest section of the breast. 2 30 cm blocks are cut from the strip and each immediately placed into separate plastic bags, which are sealed and labelled. One of the subsamples is set aside for pressing on the day of cutting. The remaining subsample is placed into a freezer at -18 degrees C plus or minus 2 degrees C and allowed to freeze for at least 48 hours. To express the intracellular fluid, meat juice, from the subsample, place the test portion into the cavity of the base unit of the press, place the lid onto the press, and manually press both halves together as shown in the first image. Then, insert the press into a G-clamp and tighten the clamp gently to hold the press in place as shown in the second image. Hang the clamp and press onto 2 horizontal rods or similar so that the press is suspended vertically and place a petri dish under the press. Tighten the G-clamp screw until the press is almost closed and the juice begins to drip from the press into the petri dish placed underneath. After allowing the juice to drip into the petri dish for 10 minutes, remove the dish from under the press and swirl it to mix the juice that's been obtained. Transfer 1 milliliter of the juice to a 25 volumetric flask and dilute the juice to a volume of 25 milliliters with phosphate buffer. Filter a necessary milliliter aliquot of the diluted juice through a 0.45 micronewton syringe filter, and as illustrated in figures 4 and 5. It should be noted that analysis of the pressed juice after dilution and filtration may be carried out on the day of pressing, or if necessary, the extracts may be stored overnight in a fridge or may be frozen at -18 degrees C. it is not advised to store unfiltered juice as it may contain small pieces of meat residue. To analyze a sample of diluted express meat juice, place a flask containing the phosphate buffer solution into a water bath at 25 degrees C for 30 minutes before use. Add 200 microliters of EDTA solution to 2.6 milliliters of pre-warmed phosphate in a 1 cm cuvette, and then add 50 microliters of NADH solution and 100 microliters of the diluted and filtered pressed juice. Cap the cuvette and mix the contents by inversion. To start the reaction, add 50 microliters of Hydroxyacyl-Coenzyme A and immediately mix by inversion. Wipe the walls of the cuvette and place it into the spectrophotometer. Read the absorbance at 340 nanometers and start the timer. After 3 minutes, read the absorbance at 340 nanometers again. The measurement procedure should be repeated with the second 100 microliter aliquot of the diluted sample pressed juice. The HADH activity of each sample extract obtained from the frozen and unfrozen samples can be determined and used to calculate a factor R1. The first step is to calculate the rate of decrease in absorbance over 3 minutes. This is done by subtracting the absorbance recorded after 3 minutes from the absorbance recorded at the start of the reaction and dividing that value by 3. Using the rate of change in absorbance, it is possible to calculate the HADH activity of the sample being measured in terms of units per milliliter by applying the equation shown on the slide. If the default volumes and dilutions described previously are applied, then the equation may be simplified to the HADH activity being equivalent to the rate of change in absorbance over 3 minutes multiplied by 119 units per milliliter. The ratio of activities, or R1, of the unfrozen sample divided by the laboratory frozen sample can then be determined, and it is this value that provides an indication of whether the original poultry breast sample had previously been frozen. As indicated on the previous slide, the R1 value is used to indicate whether the sample has previously been frozen by comparing it to the threshold values. The threshold values for poultry breast meat are 0.5 for chicken and 0.62 for turkey. If the R1 value obtained is greater than the threshold values given above, then the sample is considered to have previously been frozen and thawed. There are currently no certified materials available to use in the procedure, and it is both difficult and expensive to obtain pure HADH enzyme, so meat juice and frozen samples should be prepared in-house and used for quality assurance purposes. If this procedure is undertaken, then the HADH activity of the pressed juice employed should be confirmed by analysis before storing at -18 degrees C or -80 degrees C if available. These reference materials may be employed for control purposes to confirm that the absorbance readings are optimized. It is recommended that the HADH activities of each sample be recorded and then a vial of each solution analyzed with every batch of samples to demonstrate consistent results. The design specifications for the meat juice extraction press are shown. The meat press consists of a perspex container with a circular base unit and lid and a G-clamp. The dimensions of each of the press components are as illustrated. A G-clamp with a jaw size of approximately 100 to 150 mm is required. The precise dimensions of the clamp are not important, provided the clamp fits around the press and permits the two press halves to be pressed together. Details of the reagents needed to undertake the procedure and how to prepare the solutions used in the procedure. General laboratory or analytical grade reagents, along with deionized water, is used in preparing all solutions. The list of publications shown on the slide provide additional details for the method described in this presentation, including information on the international collaborative trial that demonstrate that the method is fit for purpose. This e-seminar has been produced as part of the Joint Knowledge Transfer Framework for Food Standards and Food Safety Analysis, and which is funded by the Department for Environment, Food and Rural Affairs, the Government Chemist Programme for 2023 to 2026, the Department for Science, Innovation and Technology, the Food Standards Agency, and Food Standards Scotland.